This is problem 837. It's on page 314. For the gear train sketched in the figure, compute the output speed and direction of rotation of the output shaft if the input shaft rotates 1750 RPM clockwise. Now, the particular figure we want to use is the one that's just below the text here on the same page as the last figure on page 314. I'm not going to copy it in the interest of time. We'll just refer to the figure. So if you're watching the video, you should open your book to page 314 and look at the figure at the bottom right-hand corner of the page. Now, there's some number of gear teeth given here, and I just want you guys to help me identify. There's gear A, B, C, D, E, and F. Can you tell me which of these gears are driving other gears? Now, the input is coming in on A.
A, C, D.
Okay, A is driving, C is driving, E is driving. Everybody see that? And what that means then is that B, D, and F are all driven gears. Now, we're supposed to compute the train value and also basically give it a positive or negative sign, whether the input and output are rotating in the same direction. So, do the input and output rotate in the same or opposite directions? Well, let's see. The shaft rotating on A is going clockwise. That means BE is counterclockwise. That means DE is clockwise, the same as the input, and so the output is actually rotating in the opposite direction.
Oh, I thought that was gear in between.
I'm sorry?
I thought that was 2 gears there.
There are 2 shafts in between them.
So the driving would be A, C, and E, right?
Correct. A, C, and E are driving gears.
I thought
The
you
driven, did I say it backwards?
said- No, I thought you said A, C, and F, so I'm trying to figure out how.
Oh, no, A, C, and E are definitely the driving gears. And then B, D, E are B, D, F, excuse me, are the driven gears. Okay, so you can tell that we're going to need in our train value, we're going to need a negative sign just to begin. In other words, the output is rotating counterclockwise. Okay? And then all we have to do is take the product of the number of teeth in the driven gears over the product of the number of teeth in the driving gears. So this is very straightforward. Okay, so driven gears, you guys told me that was B, D, and F. I agree. B, 42. D, 54. F, 54. And then we need to take the product of the number of teeth in the driving gears. You guys said those were A, C, and E. I agree. So 18 is for A, 18 is for C, and 24 is for E. So when you plug all this in, what you find is that the train value is negative 15.75. And really you can put units on here. You can say speed in over speed out, just as a note. Now really, this is equal to speed in over speed out. So you have to be a little bit careful with that. So the speed out is equal to the speed in divided by the train value. So 1750 RPM divided by the train value of negative 15.75 gives you an output speed of negative 111 RPM. And all this really means is that it's counterclockwise. That's all that means. Okay? Any questions on that?
I still don't get the negative. I mean, how you know that's a negative? Because,
Well, the negative just means opposite.
okay.
If you look at the direction of rotation, let's see. I guess I'll go ahead and sketch the system. So A is here, B, C, D, E, and then finally F. Whoops. F here. Right? Well, if A is rotating clockwise, then B is rotating counterclockwise, which means D is rotating clockwise, which means F is rotating counterclockwise.
Okay.
Any other questions? All right.